In this video, I will show you how to solve an exponential equation when the bases are completely different and they cannot be made into the same thing. There are a number of different ways to do it, but the bottom line is we're going to wind up taking the log of both sides. So I'm just spreading these out a little bit first. Leave myself room for the logs. Okay, 2 minus x. Now, really, you could do the log of any base. So in another time, I would have picked one of these bases, and I might have done log base 4, just so that these will cancel each other out later. But rather than do that, I'm just going to do the natural log to both sides. All right, turns out to be equally as simple, in some ways even simpler, than choosing one of the existing bases. So I'm just going to do natural log to both sides every single time. Okay, now that I've done the log of both sides, I can do the power rule to get this expression out of the exponent. The power rule says you can take this exponent and put it out to the front of a logarithm. So that's going to give me 3x minus 1 times the natural log of 4 equals 2 minus x times the natural log of 3. So what I'm going to do now is the distributive property. So I'm going to take this natural log of 4 and I will distribute. And I will do the same thing with the natural log of 3. I will distribute. So this is going to give me 3x times the natural log of 4 minus, well, 1 times the natural log of 4 is just the natural log of 4. And on the right-hand side, I will have 2 times the natural log of 3 minus x times the natural log of 3. Have I lost anyone so far? Okay. Now, the way you solve any problem where you have multiple terms that have x in it, you want to get all your x terms together on one side of the equation. So focus your eyes on this. This term has x in it, and this term has x in it. So I want both of those terms on the left side of the equation, and I want everything else on the right side of the equation. So see if you can follow this. I'm just going to bring down the 3x natural log 4. Because it's already on the left side of the equation. I'm going to add x natural log 3 to both sides. So the x natural log 3 is going to wind up on the left-hand side as plus x natural log 3. I'm going to bring down the 2 natural log 3. What's going to happen with this minus natural log 4? It's going to add to the other side. So I will wind up with plus natural log 4. Have I lost anyone so far? The reason why I wanted all the x terms on one side is so I can factor out the x now. X now is a common factor, the GCF. So I can take that x out in front of parentheses. And that will leave behind 3 times the natural log of 4, all right, that x came out, plus natural log 3. Okay, over here, nothing changed. So 2 natural log 3 plus natural log 4. Okay, now I'm going to use the power rule. Anywhere you see a coefficient in front of the natural log, I'm going to move that to the exponent. All right, so this 2 is going to come over and become the exponent. So that's why on the next step I will have natural log. This would be 4 to the 3rd power. What is 4 to the 3rd power? 64. Okay, so that's where this 64 came from. I did 4 to the 3rd power. So I've got plus natural log 3. On this one, it's going to be 3 to the 2nd power. What's that? Yeah, it's just 9. 3 squared is 9. Plus, yeah, don't be scared. You guys got this. Okay. Now, how could I make this sum simpler? Multiply. Okay? You can condense a sum of logarithms down to a single logarithm if you multiply. So take your 4-function calculator, which is the only one that you'll be allowed to use on the test, and multiply 64 times 3. What's that? 92? 192? Okay, 192. All right. Similarly, on the right-hand side, I will use the product rule, and I will get a single natural log of 36. So now, how am I going to get x by itself? Simply divide both sides by natural log 192. So divide both sides by natural log 192. Natural log 192. Okay? So this is as far as we can go without a calculator. Using a scientific calculator, you would get 0.6816. But on your next test, when you won't be using a scientific calculator, you would just put this first box as your answer. All right, let's do one more example. First, I'm just going to spread out the problem a little bit. So we have 6 to the 2x plus 4 power is equal to 5 to the negative x plus 1 power. So again, since the bases are not the same and they can't be made into the same thing, I'm just going to take the natural log of both sides of the equation. So then I can use the power rule, which tells me that I can take the exponent and move it to the front of the log. So on my next step, I will have 2x plus 4 times the natural log of 6, and then I will have negative x plus 1 times the natural log of 5. Next, I will do the distributive property, all right, with both of these natural logs. So I will get 2x times the natural log of 6 plus 4 times the natural log of 6. And I will have negative x times the natural log of 5 plus the natural log of 5. All right, so what I need is for both of the x terms to be together on one side of the equation. So I'm going to keep the 2x natural log 6, but I'm going to add negative x natural log 5. I'm going to add x natural log 5 to both sides. So I will end up with plus x natural log 5 equals. I need to move the 4 natural log 6 to the other side, so I'm going to subtract that. So I'm going to end up with natural log 5 minus 4 natural log 6. All right, I did that so that on the left-hand side, I could factor out x as the GCF. So I'm going to take that x and pull it outside the parentheses. That will leave me with 2 times the natural log of 6 plus natural log of 5 is equal to natural log of 5 minus 4 natural log 6. Now, all of the coefficients in front of logs can become exponents according to the power rule. So this 2 can turn into 6 squared. This 4 will become 6 to the 4th power. Okay, so that's going to give me x times the natural log of 36 plus natural log 5 is equal to natural log 5 minus natural log, what is 6 to the 4th power?
1296.
Okay, 1296. Okay, so using the product rule, I can combine these into a single log by doing 36 times 5. What's that?
180.
What?
180.
180. Okay, and now this will be a nice big number. Well, it's a fraction. So we have to do the natural log of 5 over 1296. Okay, so this one won't be as pretty, but it's okay. So in the end, we will get x by itself by dividing both sides by natural log 180. And this will be the final answer if you don't have a scientific calculator. So x equals the natural log of 5 over 1296 over the natural log of 180. So without a scientific calculator, this is the answer. If you have a scientific calculator, obviously you can type this in. So can someone give me the decimal answer?
Negative 1.0702.
Negative 1.0702. By the way, real quick, let me show you how to type this expression into your calculator. You need to hit alpha y equals. This is how you do it on a TI-84. Hit alpha y equals and enter to go into fraction mode. So then in the numerator, we have the natural log. And then inside the natural log, we have another fraction. So alpha y equals again. And then I will do my 5 over 1296. And then in the denominator, you do your natural log of 180. Okay, so that's how you type it into your calculator. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.